Yes, so good morning. My name is Avanishkumar Pathak and my teammates are Anshi Srivas and Piyush Valde. Our topic is remove high frequency noise from an ECG signal and we are guided by Sultan Banswadi ma'am. Okay, so this is index. So we are going to see in this presentation introduction, application, FIR filter, flow of project code calculations, result and at last conclusion. Introduction. So first of all we will see introduction. So electrocardiography is the process of producing an electrocardiogram ECG, that is known as ECG. It is a graph of voltage versus time of electrical activity of the heart using electrodes placed on the skin. It provides a wealth of information and remain an essential part of the assessment of cardiac patient. Here I will explain the diagram. So this first wave, that is it has three main components to an ECG, that is P wave, which represents the depolarization of the atria. After that QRS, that is middle complex, which represents the depolarization of the ventricles, and the T wave, which represents the repolarization of the ventricles. Actually from this only, that is QRS, the R peak, doctors decides whether the person is normal or patient. Next, working principle of the electrocardiograph. So it works on the principle that a contracting muscle generates a small electric current that can be detected and measured through electrodes suitably placed on the body. The electrodes pick up the current and transmit them to an amplifier inside the electrocardiograph. In an electrocardiograph, a sensitive lever traces the changes in current on moving sheet of the paper. Actually, it has 12 leads. That 12 leads are placed on the body of a person. Two leads in the left hand, two leads in the right, two leads in the on the left leg and right leg, and four on the chest. In this way they are placed. After that, application of ECG. So it indicates the rate and rhythm or pattern of contraction of heart. It gives a clue about the condition of heart muscle and is used to diagnose heart disorders. It helps the doctors to determine whether the heart is normal, enlarged, or if it is certain regions are damaged. It can also reveal irregularities in heart's rhythm known as arrhythmia. It is used by doctors to diagnose heart damage in conditions like high blood pressure, rheumatic fever, and birth defects. Next is FIR filter. So FIR filter is known as the finite impulse response filters and are digital filters that have a finite impulse response. FIR filters operate only on current and past input values and are simplest filters to design. FIR filters are also known as non-recursive filters. FIR filters provide a linear phase response. FIR filters are always stable because they are implemented using an all-zero transfer function. FIR filters are used for applications that require linear phase responses like high quality audio systems. So this is the flow of the project. First of all, we load the ECG signal from the physionet.org website database. After that, we remove the base and gain and calculating the time. After that, plotting the ECG original signal, designing FIR filter, and then filter the data into the variable, and finally we get the noise removal ECG signal. This is the flow of our project. Next code, this is our code. These are some calculations. Here we have calculated Nyquist frequency, that is fs upon 2, and after that f Nyquist we have taken 1000 by 2. So this is the norm. We have calculated normalized frequency, that is 0.1. This is the lower stop band and higher stop band. In between that is normalized frequency. So this is the database Bain and Guess calculation. This is the output of our program. So we will go directly to the MATLAB to see the program. So this is our program, and this is the figure that we get output. Here what we have to do is we have to take the file from the physio.net org, and here we have to upload that file, and after that we have to load here that file name. This load command is used for loading the file in this program, and after that we get this output, and in this output you can see that how much noise distortion is cancelled in this final result. Okay, So conclusion, ECG provides a wealth of information and remains an essential part of assessment of cardiac patients, but noise distortions associated with the signal could lead to wrong interpretation and diagnosis, so the removal of noise is very important. Hence the noise corrupted ECG signal is handled through the FIR filter and the desired smooth signal is obtained. These are some references from where we have taken some information. Yes, thank you. Any questions? Yes, thank you, ma'am.